This video will involve triangles and their side lengths. Now here's the main concept that's going to show up over and over again in this video. Imagine that we're going to form a triangle, but we know two sides of the triangle, but the third side we don't know. So imagine, for example, that this side of the triangle had length 6. And then imagine that we had another side of the triangle that we know is going to be length 4. What are the possible lengths of the other side of the triangle? Alright, so to answer that question, imagine that this corner is a hinge. And imagine that this side of the triangle swings the way you would swing a door. So let's look at the extremes. If we took this side and we swung it to the left, the most extreme possibility is that it would be completely flat going to the left. So if that was the case, in this extreme case, of course, it would not form a triangle at all because it would be completely flat. But it will serve to show us the maximum length that can possibly be made by these two sides. If you stretch it flat, now imagine that this dotted line right here is like a rubber band. Okay, let me do it in blue. So this is like a rubber band that's being stretched as we open the door. When this goes flat, then that rubber band would be stretched from one end all the way to the other. So in this case, we get the maximum length, which would be 10. Now, like I said, this would not form a triangle because it's flat. So that tells us that the third side has to be less than 10. So if this is like a side question mark, the question mark has to be less than 10. It cannot equal 10. Now let's go to the other extreme. What if I turn it to the right? And I turn it to the right until, again, it's flat. So remember that this has length 4. So in this case, that rubber band side, the third unknown side, is going to be right here. So if the longer length is 4 and this if the longer length is 6 and this shorter length is 4, that means the question mark, the minimum is equal to 2 in this case. That must be a 2. Alright, but it can't equal 2 because that makes it flat again. So that gives us a lower boundary. So this question mark length has to be greater than 2. Okay, so rather than calling this a question mark, let's call it x. So the length of this unknown side has to be between 2 and 10. So I could say 2 is less than x, which is less than 10. So in this problem, Fiona's school has 3 hallways that make up 3 sides of a triangular building design. In the morning, Fiona walks 90 yards through the first hallway to get to the next. In the afternoon, she walks 60 yards through a second hallway to get to exit the building. What are the possible lengths of the third hallway that she did not walk through? So, okay, we had the whole paragraph, but the bottom line is we have two sides of a triangle. This side is 90. This side is 60, and we have the unknown side, just like in the picture I was drawing for you a minute ago. Okay, what are the possible lengths? So again, think of this as a hinge. If I swing this side down, it will give me the lower boundary. So if I were to swing this all the way down until it became flat, it would land here. Okay, maybe I should make this pink, red. So remember, this is 60. So if I put it flat, then this red part is 60 against the 90. Okay, so this unknown length would be right here. Alright, so what's the difference between 90 and 60? Well, that's going to be 30. So that's the minimum. So I'm going to write down 30. So 30 is less than x. Okay, this is the lower bound. Alright, so this side has to be bigger than 30. On the other hand, if we were to rotate this side in the other direction, if we were to rotate like this, okay, until it became flat in the other direction, alright, so in this case we have the 90 here, and now the 60 would now be here. I ran out of space on my paper, but you get the idea. So we'd have the 90 and the 60. That's going to give us the upper bound. Okay, so this is going to be 150 is the maximum length that these two sides can possibly make. To make 150, it would have to be flat. So that doesn't make a triangle. So the length of the third side has to be less than 150. But that's the upper bound and the lower bound. So 30 is less than x, which is less than 150. Alright, it's got to be between 30 and 150. Okay, so that means the fourth answer is our answer. Kabam! Alright, let's look at the next one. In triangle XYZ, angle Z is greater than the sum of x plus y. And then they're asking us which of these statements must be true. So Z is greater than the sum of the other two. So let's play around with that for a minute. Imagine that Z was 90 degrees. Remembering that the sum of the angles in a triangle always adds up to 180 degrees. If one angle is 90, then that means the other two angles have to add up to 90, because that makes 180. So if one angle is 90, for example, maybe angle X is 45 and angle Y is 45. Alright, 45 plus 45 is 90, and then plus the other 90, that makes 180. So in that case, angle Z equals the sum of the other two. And it would be the same no matter what I picked for these two angles. They don't have to be the same. Say if this one was 40 and then this one was 50. Okay, if this is 90 degrees, then the other two have to add up to 90 degrees. That makes them the same. Alright, angle X plus angle Z equals, angle X plus angle Y would equal angle Z in this case. But angle Z is supposed to be bigger than the other two. Alright, so the only way that it could be bigger than the other two is if angle Z is bigger than 90 degrees. So angle Z must be obtuse. Okay, this is an obtuse angle. This angle is bigger than 90 degrees. Alright, so Z is greater than 90. That means angle X and Y, the sum of X and Y has to be less than 90 degrees. Okay, so angle Z is bigger than 90 degrees, and angle X plus angle Y has to be less than 90 degrees. Okay, so let's see if any of those things are here. Let's see. Angle x plus angle z is less than 90. Well, angle z has to be bigger than 90 already, so we're not going to add something to it and then suddenly it'll be less than 90. So that one is wrong. Angle y is greater than 90. That's also impossible because angle z already has to be obtuse. You can't have two obtuse angles in the same triangle. You can't have two angles bigger than 90. So that can't be it. X and y are complementary. Complementary means they add up to 90. That can't be true either because that's what I was showing you at first. If x and y add up to 90, then that means angle z has to equal 90. But that would make them the same. But angle z has to be greater. So that one can't be true. So it must be the last one. Angle x plus angle y is less than 90. And yeah, that's what we said right at the beginning. So this one is definitely true. Alright, let's look at the next one. Triangle QRS has the angle measures shown. Let's draw a picture. Alright, drawing not to scale. So QRS. Alright, the measure of angle S is 6x. The measure of angle R is 3x. And the measure of angle Q is 1x, or we could have just said x. The measure of the obtuse angle equals what? Well, the sum of the angles in a triangle is always going to be 180. So let's use that to write an equation. So 1x plus 3x plus 6x has to equal 180. Okay, so that's going to be 10x is equal to 180. Dividing both sides by 10, x is equal to 18. Okay, so if x is equal to 18, so this is 1x, so that means angle Q is 18. And this is 3x, so 3 times 18. So that is 54. And then 6x, so 6 times 18, which is 108. Okay, so this is the obtuse angle, and that's 108. And there you go. Alright, this picture is illustrating why sometimes three lengths cannot form a triangle. So let me put some numbers on this, like a hypothetical. Imagine that this was 10, and imagine that this was 4, and this was 3. Why could this never make a triangle? So again, imagine hinges. Imagine that this is a hinge, and so imagine that we can swing this back and forth. And imagine that this is a hinge also. Okay, right now these are not touching. So we would want to swing these down like we're closing a bridge to bring them closer together. But the problem is, imagine that I swung this all the way down until it was flat, just to make a point. Okay, this would come all the way down and hit right here. Okay, so this distance, okay, that formed by swinging this down, this is a length of 4. Now imagine that I swung this one all the way down, same thing. Can you see what's happening? Okay, this has a length of 3. what happens if you add up 4 and 3? 4 plus 3 is only 7. That's the problem. The third side of the triangle is 10. So if I move a distance of 4 from the left and a distance of 3 to the right, they will never meet because they have a total length of only 7. Even if I had two numbers that added up to 10, that wouldn't be good enough. It would be no good. Imagine that this was 4 and this was 6. 4 and 6 equal 10, but the only way that they would touch is if I flattened them out. If I rotated this flat until it went like this, and if I rotated this one flat until it went like this, then yeah, they would just barely touch. This would be 4 and this would be 6. That makes 10. But there would be no extra space left over to make the triangle. They have to be bigger than 10. So if these two sides add up to less than 10, it will not make a triangle because they will never reach across. So which inequality explains why these segments cannot be used to make a triangle? So we're talking about this, but instead of using these numbers, we have to use the letters. So, you know, this is DE, or it looks like they're calling it ED, so I will too. So this is ED, and we have EF, and we have DF. Alright, but just like when we had 4 and 3 and 10, this will not make a triangle if ED plus EF is less than DF. Alright, if these two sides add up to less than the third side, they won't reach. So this is the answer that we're looking for. So let's see. This has greater than, so that's not going to be it. If it was greater than makes it be a triangle. So it's not going to be either of the greater thans. So maybe it'll be this one. ED plus EF is less than DF. Yes, that's why you cannot make a triangle out of this, because these two sides add up to less than the third side. They won't reach. Okay, this is just like the black screen that I showed you at the very beginning. Let's see, 12 and 15. Let's go back to this again. Okay, I'm just redrawing it here so I have space. Again, imagine that this is a hinge. I want to know the possible lengths of this third side X. Think of this as a rubber band. If I swung this side down, alright, as the more I move this down, the shorter this rubber band is going to get. So the shortest this rubber band could possibly be is if I rotated this until it was flat. So if I rotated this until it was flat, okay, then the 12 would be right here. The rubber band would be right here. Okay, if this is 12 and the longer side is 15, that means the rubber band now has a length of 3. So that is the smallest length the rubber band could be. Alright, so 3 has to be less than X. Alright, it can't equal 3 because that's flat. That's not a triangle. Now, you will get the biggest length of the rubber band by rotating in the opposite direction. So if I took this and I rotated it the other way, like this, until I made it flat, okay, that's going to make the rubber band stretch. Like every time you move it to the left, this rubber band is stretching longer and longer until finally it is stretching from one end of this thing all the way to the other. This is the longest you could make that rubber band be. But remember, this is length 12, alright, because it's this side rotated. This is length 12. So if this is 12 and this is 15, that's going to be 27. So this rubber band, in this position, the rubber band has length of 27. Okay, so that is the upper bound for the length of this side, is 27. So the third side has to be less than 27. It can't equal 27 because to make 27 you would have to be flat, and that's not a triangle. So the third side has to be somewhere between 3 and 27, non-inclusive of 3 and 27. Okay, so the value of x must be greater than 3. Okay, and less than 27.